A block and a trolley system is connected as shown in the figure. It's over here. Determine the acceleration of the system and the tension in the string. So obviously, okay, let me explain. Coefficient of kinetic friction between the trolley and the surface, which is 0.3. So this is mu k is 0.3. Assuming the acceleration due to gravity is, okay, that also has to be taken into account. 0.3 mu k is equal to 0.3. Okay, first thing first, let's write the obvious. So we have here 30 Newton. This is 200 Newton. And so we have, this will be 200 Newton. And this is your normal force. And this is your M into A. And this is your mu 0.3 into 200. That will be 60 Newton. F of K. Done. Right? So the system is moving forward. If this is accelerating with A, this too will accelerate with A because of the fact that this is a string, massless string with no, which is not going to get, it's not non-elastic. Yeah. This is the tension over here. The same tension will exist over here as well. Again, massless and all of those properties makes this possible. Right? Okay. So what is that we need to figure out though? Determine the acceleration. Quite simple. If you guys remember, he is a person who earns, and here we have someone who not only earns but is also, not only uses the earning, he is also not the consumer, plus he will spend also. Is spending, and of course we have the consumers to be two entities. Okay, I'll erase this. Let me go to what I mean over here. So with this being the case, you need to understand that the total mass is how much system's force is coming from where, and so on and so forth. So first is, I'll talk about system's mass. That would be 20 plus 3. This is 23 kg. The system mass is because of mass of the block plus the trolley. So this is the trolley and this is your block. Now we have systems force. So we have 30 minus, just a second. So 3 kg, what did I miss? 0.3, 20, 60. Technically, the question is not wrong. I mean, we have 60 and this tells that we don't have the system to move at all. I mean, technically, this scenario setup will not let the system move. So basically, this trolley will stay there and this block will not go down. Here, the acceleration is 0 technically for this value. But if I change this to 0.03, then yeah, we can do something about it. Then this will be 6. Okay, guys, that question was not wrong. Okay, if it was 0.3, then this would have been 60. So 60 cannot be pulled by 30. And since this is kinetic friction, obviously your static friction, the maximum value that is possible will be more than 60. And so technically this value will not be practical. The 0.3 value wherein we see any kind of friction, any kind of movement, that is not going to happen. But if I change it to this, then yeah, this is possible. System forces are 30 Newton and 6 Newton, right? So this is because of, let me actually write it. System forces involves pull down by gravity. So this is 3 kg block minus the frictional kinetic friction of trolley. Okay, so this is the math. So this is 30 minus 6, that is 24 Newton. So this is the source of our push and pull. So we have the system force, we have the system's mass. Then what we can do here is now we can figure out the system's acceleration. System's acceleration will be seriously 23 by 24 meter per second square. Okay, I wrote the ulta values. No, I did write the ulta values. So 24 by 23. This is the force and this is the mass. Okay, if it's so, it is so. I made up this question. So I have to go through this. Okay, we have 24 and 24 by 23. Now we know the acceleration. We just have to determine the acceleration and the tension. So from the point of view of T's point of view, what is that we are looking at? We have a block, we have a tension, we have it, 6 Newton also pulling back, and then at the same time we have an acceleration of 24. I'll just write it as A, and it's pulling 20 kg. So this is what from point of view of T looks like. So second law, Newton's second law, tells that we have the net force is equal to mass into acceleration. If I consider right as positive, so we have T minus 6 is equal to mass is 20 kg, acceleration is 24 by 23. All this is not practical value, but okay, we'll just do something with this. So this will be around 27, I guess. 24 by 23 minus 6. Wait, what? Oh, sorry, plus 6. Yeah, I guess. Oh, no. What am I telling? How is that possible? 23 plus, okay, not 12, my bad. 6. I mistyped. Typo error. 26.9 Newton. Right? That will be the tension. To the right.